Okay. Good evening. Can you hear me? Can you hear me? Yes. Okay. Last day we discussed up to third structured question. No, I am finalizing your marks. I think today I can send you marks. Last day I sent. I finalized 27 students' marks. Your marks still not finalized. Okay. All MCQ questions discussed and structured part micrometer screw gauge question discussed. Today we have third structured essay. Third structured essay. Okay, let's start. Question number 3. You are required to experimentally find a value for the latent heat of fusion. Fusion means melting. Okay, fusion is a equal word. Same word. It is melting. Melting. Melt. Solid convert into liquids. That's the meaning of melt. Solid. That means ice cube dissolve into water. Convert into water. Okay, that's the meaning of melting. The latent heat of fusion. Latent heat of fusion means the latent heat of melting of ice using calorimeter with water based on the theory of mixture. Theory of mixture means, do you remember in heat lesson we have a specific part, the mixture method? Do you remember? Mixture method. Mixture method කියලා part එකක් තිබ්බ මතකයි? Do you remember? Mixture method. Based on using this mixture method, we can calculate the specific latent heat of melting. The question given based on the experiment of mixture method. Experiment of calculate the latent heat by using mixture method. Okay. Define the specific latent heat of fusion, that means melting. Define the specific latent heat of melting of ice. Okay, how to explain? Okay, first, what is the meaning of latent heat? Do you remember? Latent heat. What's the meaning of latent heat? Okay, specific latent heat we can discuss later. What's the meaning of latent heat? Dihini matakayද? What's the meaning of latent heat? Oh, hidden heat කියලාත් කිව්වා. සැඟවුණු. Hidden heat. What's the meaning? Yeah, they are very important. What's the meaning of latent heat? Latent heat. Latent heat. Not specific latent heat, just simple latent heat. What's the meaning? Yeah, very good. The amount of heat, they are very important. We already discussed the amount of heat absorbed or released. The amount of heat absorbed or released. If it is melting, it's absorbed or released. In the melting process, is it exothermic or endothermic? Tanya, melting can exothermic or endothermic? Very good. Endothermic, absorbing. That's why heat absorbing. That's why it's convert to liquid. Okay, melting. Now the amount of heat absorbed or released in a physical state change. Physical state change. In a physical state change, as example, I'll explain an example. Okay, what's the meaning of latent heat? The amount of heat absorbed or released in a physical state change without any temperature difference. Without any temperature difference. Without any temperature difference. Temperature difference. The amount of heat absorbed or released in a physical state change, in any physical state change, but without any temperature change. That's why without temperature change, some amount of heat absorbed or released. That's why we called as it's a hidden heat or latent heat. Remember, Sabir? As example, think 0 Celsius ice. 0 Celsius ice cube. If we supply heat, it's converting to 0 Celsius water. What is this process? What is the name of this physical state change? 0 Celsius ice converting to 0 Celsius water. What's the name of the physical state change? Fatima, quickly. 0 Celsius ice convert into 0 Celsius water. Yes, that is a melting. During melting, the amount of heat absorbed, this Q is a latent heat. The amount of heat absorbed during a physical state change without any temperature change. Now you can see same temperature without any temperature change. Then what happened to this heat amount? Without absorb karne ka what is the purpose and what is the function of this absorbed heat? What happened? What happened to this heat? I already explained. What happened to this heat? Kavir? Now, in melting process, part of heat energy, yes, they used to break down bonds between molecules. Very good. They used to break down bonds between intermolecule bonds that we call as breakdown intermolecule bonds. Argol bonds. Now you know solid mean they are highly compacted. Their molecule structure highly compacted. No, they are highly compacted like this. Highly compacted. What happened? When it is reached to melting point, melting temperature, that's the maximum temperature they can retain as a solid. Are the meat tolerate maximum temperature at maximum at with solid bonds with strong intermolecule bonds. This is a maximum. 0 Celsius is a maximum. 0 Celsius. If you got ice, that's the maximum retain capacity of molecule to increase the kinetic energy with these bonds. Strong bonds. Then what happened at 0 Celsius when it is continuously provide heat? Continuously heat provide what happened? Some part of this heat energy used for bond breakdown. Break down their available bonds and it's converted into liquid form. Liquid form like this. They don't have more strong intermolecule bond. It is less strong. මෙයාට වඩා bond strong එක අඩුයි. Understood? Okay, that's the meaning of latent heat. That's the latent heat of melting. But this is not the specific latent heat. Now you should know. You have to revise what's the meaning of specific latent heat. specific latent heat, specific latent heat, specific latent heat. Specific latent heat we called latent heat, that we called as capital L, specific latent heat. Okay, how we can explain how we can define the specific latent heat? Remember the amount of heat, the amount of heat absorb. Now it is melting, now absorb. Okay, now release, absorb. The amount of heat absorb to completely, the amount of heat absorb 1 kilogram of solid, 1 kilogram of solid substance or ice substance at melting point. Melting point, that means 0 Celsius. Melting point to completely convert into liquid state without any temperature change. Temperature change. Okay, I got short form. Okay, the amount of heat absorbed, the amount of heat absorbed by 1 kilogram of solid substance at melting point. Melting point means 0 Celsius. To completely convert into liquid state without any temperature change. Remember, this is a full definition of the specific latent heat of melting. This is the answer. The amount of heat absorbed by 1 kilogram of solid substance at melting point to completely convert into liquid state without any temperature difference. Without any temperature difference. Hari, are you good? Dihini correct? The amount of heat absorbed, now in melting it is endothermic, now therefore absorbed by 1 kilogram of solid object. 1 kilogram of solid, that means 1 kilogram of solid, 1 kilogram of ice cube. And 1 kilogram of ice cube. It's a 1 kilogram of ice cube at melting point. Melting point means 0 Celsius. Ice cube 0 Celsius to completely convert into 1 kilogram of liquid. It is ice. This is liquid or water. Water. Same, without any temperature change. The amount of heat absorbed is the that's a short form. This is the specific latent heat of melting or fusion. Okay, how we can modify? Then now you have idea about what's the specific latent heat of melting. Now, can you modify this definition and concept into specific latent heat of vaporization? කොහොමද අපි modify කරන්නේ? Okay, the amount of heat, the amount of heat, the amount of heat in vaporization, it's that one also absorbed. Now, endothermic, the amount of heat absorbed by 1 kilogram of liquid. Now 1 kilogram of liquid substance, 1 kilogram of liquid substance at which temperature? Vaporization, vaporization, that means liquid convert into gas. What is the temperature name? It's point එකකට මොකක්ද කියන්නේ? දෙහිනේ. What's the name of this point? Previously for ice, very good, it is boiling point. The amount of heat absorbed by 1 kilogram of liquid substance, ඒ කියන්නේ වතුර කිලෝ එකක්, at boiling point, to completely convert into gas state, without any temperature change, Okay, this is the definition of the specific latent heat of evaporation. For make an question again, the question asks what is the specific latent heat of fusion, no? Its previous question, previous definition. State its unit. Specific latent heat unit. Okay, specific latent heat mean specific latent heat, Q equal ml is the equation, right? Q equal ml is the equation. Q equal ml, then if you isolate L equal Q over M, right? L equal the specific latent heat equal the amount of heat absorbed during this process divided by mass per 1 kilogram. Then you can get the unit joules divided by kilogram. Kg, j kg minus 1 is the j kg minus 1 joules per kilogram. Joules per kilogram is the unit. J kg minus 1 is the unit. Okay, large ice cube and small ice pieces, body ice pieces given for this experiment, they have supply. What other equipments required for this process? Okay, up to say this B part actually based on practical questions. Okay, that's, we don't have discussed practical earlier, no? Okay, I'll only explain answers, but when we discuss our practical sessions, you can get full idea what is this experiment. This is a simple experiment. That's regarding simple experiment. Okay. What other equipment is required for this? Okay, the small and large ice cube supply. Okay, we need, okay, write down answers. I have given full marks for this practical part. I have given, if you write any answer, I have given marks only for this exam. What other equipment is required for this? Write down calorimeter. Calorimeter. Write down next one. Net style. Net style. Net style. Again, we need thermometer. 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 And asbestos. Asbestos sheet. Asbestos sheet code. Sorry, asbestos sheet we don't need. Asbestos sheet only second experiment. Okay, they are the experiment equipments. I will explain very simply here the practical. In practical class, you can get the full idea. Okay, this is a practical. It is very simple mixture method practical. Okay, first of all, we have to select. We have to select this type thermal insulated container that we call as calorimeter. That we call as calorimeter. Okay, calorimeter ka gun. Calorimeter. And you can mark the, you can get the mass of empty calorimeter. You have to use triple beam balance also required method. Triple beam balance to get the measurements. Triple beam balance. Okay. Okay. First step, you need the empty mass of the calorimeter mass. I record this one M1. M1 is the empty calorimeter mass. Empty calorimeter mass M1. Okay. Second, you have to fill water up to this level. You can fill water. Again, you can get the temperature. Calorimeter plus empty calorimeter plus water, it's M2. M2 is the mass. Calorimeter plus water. Water the applicatka mass using triple beam balance. Okay, next, you have to get the initial temperature of the system. Using thermometer, you can get the initial temperature. Third data, initial temperature. Initial temperature of the system, it is theta 1. Theta 1. Initial temperature. Initial temperature. Okay. Now, the experiment has supply large ice cubes and small ice cubes, small ice pieces supply. Okay, which one is more suitable? large one or small one. Small ice pieces more suitable than large, because large ice pieces it take more time for melting, no? But small ice pieces easily we can dissolve in water. Then after record the initial temperature, one by one, now large pieces, large ice pieces you don't need. I'm going to get small ice pieces. Okay, I'm going to get one by one small ice piece into this calorimeter. Now I told we have to use net stir. What's meaning of net stir? Net stir එකක් කියන්නේ මොකක්ද? What's the meaning of the net stir? Fatima. Net stir එකක් කියන්නේ any idea? Net stir. Stir mean stir එකක් කියන්නේ Tania? Stir එකක්. Stir mean mixing equipment. That's a equipment used for mixing the solution. අපි stir එකක් අපි කියනවා සිංහලෙන් මේ mixed නැත්නම් මන්තයක් කියලා කියන. හරි. Now think this is the net stir. Net stir, like it is this shape. This is a stir handle and it has a net like pocket, like it is a net stir. Make a net එකකින් තමයි හදලා. Net stir. Okay, when we add these small ice pieces, we have to use this net stir and dip into water. Why? If it is dissolve, if it is float, normally ice floating on water, when it is floating, it's come to heat from environment එකෙන් heat එක ඇවිල්ලා melt වෙන්න පුළුවන්. Okay, therefore it's a experiment error. Coming experiment errors, that's why we use net stir. Are you good, Fatima? Why we use net stir? To dissolve ice pieces inside the water. That's our purpose. Dip into water. Completely dip into water. Kabir, understood? Now, after 4 to 5 ice cube dissolve in water, fully dissolved, that's been melting. After melting, I can get the final temperature, final mass of the solution. Final mass means calorimeter plus water plus ice. After adding ice, the temperature M3. Temperature M3. M3 is the temperature. M3. 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 Then fifth one, we can get the using thermometer, we can get the final temperature of the mixture. Final temperature that we call a special name. Practical that we call special name final minimum temperature. Final minimum, that's important. Final minimum temperature. Minimum temperature. Final minimum temperature. It is theta 2. Initial theta 1, final minimum temperature. Finally, minimum temperature. Okay. Very low temperature. Minimum in a temperature, that is theta 2. Theta 2. Okay. Next, I need, yeah, they are the data of the experiment I got. Additionally, we need specific heat capacity of water. I consider it as CW. 7 specific heat capacity of calorimeter. I think it has C copper because it's a copper calorimeter, C copper. Okay, they are the data and this is the experiment. Understood or not? Okay, if not, we can discuss fully experiment in our practical classes. Don't worry. Actually, I put this question into the paper. You should understand, if you know full lesson, still you can't answer some questions. You can't answer. You have to completely, you have to practice practical parts as well. You have practical, another practical huge book. I'll give you English translate version. I will give you after April. Yes, after we complete 90% of lessons, we can start practical guide. Okay, it's not a simple task. Actually, we have a huge workload, but time limited. Therefore, don't waste any minute and try to do your maximum within these 5 months. Do you use large ice cube or small ice cube for this test? Small ice cubes. State the reason for rejecting other category. Other category mean large ice cube. What you reject? It's take long time for melting. It's take long time for melting. When using ice for this testing, what is the essential process you should follow? Okay, the essential two process. The main point, when you add ice into this experiment, you have to wipe these ice cubes by tissue papers. What's the purpose? Now think, this is ice cube. Using tissue paper, we have to wipe out. What's the reason? Because this ice cube, the surface of the ice cube, it has already melted water. සාමාන්‍යයෙන් අපේ ice cube එකක් ගත්තාම මේක වතුර වගේ තියෙනව නේද? Yeah, that's already melted. Okay, when this water, if we add into our experiment, it's coming measurement errors, instrument errors. Okay, that's why the essential step, we have to wipe out the already melted water molecules. Wipe the melted water on ice cube using tissue papers. That's the essential step. Okay, it has reason. How does it affect the outcome? That means result. If it is not done, අපි wipe කරේ නැත්නම් මොකද වෙන්නේ කියලා අහන්නේ. What happened if we not wipe, and if as it is, if we add into the beaker, add into the calorimeter, what happened? The amount of heat absorbed, the amount of heat absorbed by not equal to the water release heat. Water release heat. Okay, that's the effect. Normally අපි wipe කරලා දැම්මම, when we add ice after wipe out, well, dry ice අපි දැම්මම, the total amount of heat absorbed by for this melting, it is absorbed by water. But if it is already melted in outside, the heat absorbed, the heat absorbed kare outside, then it's coming experiment errors. Okay, that's why if it is not wipe out, the amount of heat absorbed by ice cube not equal to the water release heat. It's not equal to water release heat. Okay, that's the reason. How do you avoid heat transfer with environment while performing this test? Yes, actually, then make a. Okay, what's the purpose of this test? The metric finally, in this experiment, finally, we can get a result. The ice absorb heat, according to mixture method, ice absorb heat completely equal to the water plus calorimeter release heat. Okay, that's the final result. Understood? The ice absorb heat for melting, it is equal to the water release heat plus calorimeter release heat. Okay, that's the final result. For this process, we have to avoid heat transfer with environment. Okay, what we can do? What are the we can use thermal insulated container or calorimeter. Thermal insulated material made calorimeter used for experiment. There are other mechanisms. I will explain everything in the our practical classes. Now I just simply explain. මේකට තව option තියෙනවා. තව methods තියෙනවා. We have another method as well. Mention readings you obtain in the test with suitable symbols. Okay, what you need to got? Calorimeter mass M1. Write down calorimeter plus water M2. Initial temperature theta 1. Calorimeter plus water plus ice mass M3. And we need another one, max final minimum temperature theta 2. That's all. That's all. Experiment. Mention readings you got. Readings ganna mechara. Readings only 5. Okay. From that reading, write an expression for the specific latent heat of melting. Okay, let's write. Okay, I will write on the board. The ice absorb heat equal to the water plus calorimeter absorb heat. Sorry, calorimeter release heat. This is a base. This is a base. Then we can get ice absorb heat only ml plus mc theta, right? Because 0 Celsius ice convert into 0 Celsius water and it's come to theta Celsius water. Okay, it's equal to water release heat mc theta, calorimeter release heat mc theta. Okay, mass, ice mass. How to get the mass of the ice? හරි. දැන් මට කියන්න මෙන්න මේ data වලින් method M1, M2, M3 වලින් what is the mass of ice? දෙහිනි. What's the mass of ice? M1, M2, M3. We have 3 mass measurements. Very, very good. M2 minus? No. Yes, M3 minus M2. That's the mass of ice. Very good. M3 minus M2 into L. L we don't know. We make a special diagram. L we don't know. Plus mass of ice M3 minus M2. Specific heat capacity of ice C into theta. Now what is a theta? It's come to 0 Celsius to theta. Now it is theta over theta minus 0. Theta minus 0. Theta minus 0. Theta minus 0. Theta minus 0 equal mass of water. Tanya, by this data, how we can get the mass of the water? Mass of water. Habir? Very good. M2 minus M1. Calorimeter plus water. Calorimeter අයින් කරා that is a M2 minus M1. M2 minus M1. Specific heat capacity of water, CW. මේකත් අපි CW දාමු. Ice mean water specific capacity. Theta. Temperature difference. Temperature difference. Very good, Tani. Temperature difference. Temperature difference. Water temperature difference. Initially water theta 1, right? Finally it's come to theta 2. Then what's the temperature difference? Theta 1 minus theta 2 plus mass of the calorimeter. Mass of the calorimeter M1 calorimeter, empty calorimeter M1 into specific heat capacity of calorimeters copper Z into temperature difference same as water difference, theta 1 minus theta 2. Okay, that's a final expression. Okay, this is the answer. Mathematically, hurry, but I'll give you marks for this part. Okay, my target, you should identify the importance of the practical practical discussions. For practical discussions, first of all, we have to cover at least more than 80% of our syllabus, our basic theory lessons. Okay, therefore, what is the today date? Today 8. Now, within February, let's try to start our electricity now complete. More than 80% electricity complete. Then we have only magnetic fields and transformers. Then let's try to complete at least another lesson within this month, February. Next month, I hope to start our very important 2 lessons. Api 2 lessons karna next month within March. Industry chemistry and natural products. Industry chemistry and natural products. After that, April we can start statistics. Therefore, this most important lessons doing in Wednesday classes. Wednesday within 3 days use කරන්න පුළුවන් lessons දෙකට, industry chemistry and very interesting lessons, no any calculation, only theory, but all industries I'll give you a full idea with diagrams, videos and everything. Then without anything by heart, I will explain how to remember everything, how to remember everything about soap production, biodiesel production, paper production, phosphate fertilizer production, what else, paint production, everything I will step by step I will explain it. Any question, most probably essay questions, essay part, chemistry essay part mainly coming based on environment chemistry, natural product and industry chemistry. Then I will more than 90% questions based on those 3 lessons. Polymers only 2 to 3 times only. Okay, therefore next month theory lessons very important. I have to use I'm going to use one revision class time for theory discussions from next week. Okay, I will inform you after this paper. uh, one day enough for revisions, Tuesday enough for revisions, another both day I hope to get for theory classes. Pigment එතකොට අපිට end of April we can again get this time full 3 days for revisions because we can complete all theory lessons before at the end of April. Okay, don't think you have more times. You have very limited time. But have only few weeks for working. Therefore, take your time management very important, and not only SFT, other subjects also try to complete your syllabus as soon as possible. Don't worry about SFT. You have to worry about other subjects. You have to complete your syllabus as soon as possible. At least May with if not, you will get trouble because according to information, no any extension exam, the exam will be held on time. It is in August. Okay, this is the answer. Then you can isolate the L. L you can isolate, but no need for answer this that enough. Our target calculate the L. Calculate the L. What reading should be taken more carefully when taking readings? Yeah, the most careful reading. M3 is the most careful reading. That means calorimeter plus water plus ice. This reading is a more careful reading because when we add very small ice cubes, when it is dissolved in water, the mass increasing by very only 0 point value, 0 point gram value. That's therefore we have to very careful about M3 reading. M3 reading. Therefore we have to careful about more M3 reading. Okay. Okay, let's start essay questions. A monument constructed by 4 teachers, they consist of a square-based pyramid made of brass placed on the top of cuboid made of wood. The base of the cuboid is square with 20 centimeter and the height 20 centimeter. The slant height of the pyramid, I told it's changed into 20, no? 20 the කරගන්න කිව්වේ දෙහිණි 20 centimeter or 50. 20. Hi. Okay, this is a question. Okay, this is a cuboid and the prism is a square-based prism. Hari. Question number 1, find the total height of the monument. Total height of the monument. Okay, okay. If you have any mistake or any unclear point, please ask. and every step you have to write down on your explanation books, as I told earlier, to maintain a book. Find the total height of the monument. Okay, the total height mean up to this level, it is 20, no? 20 centimeters. But, okay, first of all, up to this level, it's 20 centimeter. 20 centimeter. And how about base? Base also 20, no? That one also 20. Make it 20. Okay, first of all, you can get this type line. Okay, this type line. Now this is a right angle triangle. This yellow color line, this is a right angle triangle. Right angle triangle. And up to this level, this part is 10 centimeter because midpoint. Okay, now it is right angle triangle. The hypotenuse 20 centimeter. First I want to get this x side. 20 centimeter for part 1. 20 squared equal x squared plus 10 squared. 400 equal x squared plus 100. Now x squared equal 300 squared. 300. X equal 300 square root. 300 square root is x. But what is my requirement? To calculate the perpendicular height. Now you can you understand? Think this is a midpoint of the perpendicular height of the. How about this length? That one also 10 centimeter because midpoint we have got 10 centimeter because total it's a square 20 centimeter. Now you can get x equal square root 300. Now this is a right angle triangle. Root 300 squared equal 10 squared plus h squared. Root 300 squared 300 equal 100 plus h squared plus h squared. Okay, 100 it into this direction, it is 200 equal h squared. Okay, h equal 200 square root, no? 200 square root, you can say 100 into 2 square root. Then h equal 10 root 2 centimeter. 10 root 2 centimeters. Okay. This point to the top point, it is 10 root 2 centimeters. 10 root 2 centimeters. Okay, how about the total height? Total height. This is not the total height. This is a pyramid height. Then we can say the total height of the monument. The total height of the monument. The total height of the monument. Oh my God. That's stuck. හරි තේරුණාද අපිට ආයෙ ලියන්න වෙනවා. Could you understand? Then total height equal 20 plus 10 root 2. 20 plus 10 root 2. You can get the answer. Okay. Could you understand or do I need to explain again? Make a stuck වෙලා අපි ලියපු ටික නැති වුණා. අබේ all understood? Okay, what's the answer? Okay, what's the answer? Yeah, 24.14. 24.14 is the total height of the momentum. Not monumentum. Question number 2, calculate the volume of the glass used for this pyramid section. Calculate the volume, full pyramid section only. Yeah, this is a wood part, no? The pyramid section only they asking. Okay, how to calculate? Question number 2, pyramid section. Okay, I will draw it again. Sorry, pyramid. Okay, you got this height was 10 root 2. 10 root 2. Okay, question part 2. Question part 2. What is the volume of the pyramid section? How to calculate the volume of the pyramid? 1 over 3 into base area multiplied by the height. Base area multiplied by the height. Okay. 1 over 3. How about base area? Base area 20 into 20, it is 400. 400 square centimeter multiplied by height 10 root 2. Okay. Can you send your answer? One over 3 into 400. 10 root 2 means 4.14. 4.14. Fatima? $552. 552 cubic centimeter. 552 cubic centimeter is the answer for pyramid section volume. Question part 3. If this plan is to paint only the square base of the cuboid, calculate the total surface area to be painted. Only square bases. Only square bases. Yeah, then how many square bases? 20 into 20, no? 1, 2, 3, 4, and 5. The above side don't need because it is connected to a pyramid. Now, question part 3. Total surface area to be painted. The base area 400. 400 into 5 surface, 2000 cubic centimeter need to be painted. For the decoration, 4 metallic hemispheres are used. The total volume of metal is 9702 cubic centimeter. Show that the radius R of each hemisphere is given by. It's a good question. The decoration, 4 metallic hemispheres are used. The total volume of metal is, that means for all hemispheres, for all hemispheres, 9702 is the hemisphere. Show that the radius of each hemisphere given. Simple. Question part 4. Okay, hemisphere. Hemisphere means part of sphere, no? Part of sphere. Okay, what's the volume of hemisphere? Equation. That's it. 4 over 3 pi r cube is his sphere. Hemisphere 2 over 3 pi r cube. You have to remember. 2 over 3 pi r cube. What's the volume? 9702. Instead of 5, better use 22 over 7. Okay, now 9702 multiplied by 21. $88, 22 into 2, sorry, 44. 44 r cube. Now r cube be equal yes. R cube be equal 4630.5. Yeah, according to given hint. Yes. 4 metallic spheres. 4 metallic spheres mean multiply by 4. Yeah, that's the point I have missed. 4. Then 44 multiplied by 4. The value 176. Yes. Now we can get 1157 0.6 cubic root. That's only. මෙතෙන්ටකම් විතරයි අහන්න because answer already given. R equal, you have to show this answer. If you got correctly, this is the answer. That enough. That enough. Okay, let's move into final parts. B. Show that the volume of a closed hemispherical tank with radius 3 centimeter and closed right circular cylindrical tank of 3 meter, radius 3 meter and height 4 meter are equal. Show that the volume of closed hemisphere tank. Okay, first understand the question. The volume of closed hemisphere tank with radius 3 meter and a closed right circular cylindrical tank with radius 3 meter. Okay, first of all, let's draw these two tanks. This is a hemispheric tank. How about radius 3 meter? The volume equal to the right cylindrical tank, radius 3 meter and height 4 meter. Radius 3 meter and height 4 meter. We have to show this. That's volume. Volume same. If it is same, first of all, you can find the volume of this is sphere. Phi r cube mean 3 into 3 into 3, 27. 27 into 4, 108 pi over 3. That means 36 pi square cubic meter. That's the volume of the sphere. Okay, how to get the volume of the cylindrical? Let's see, V equal 1 over 3 phi r squared h. You have to remember equations. Phi r squared mean 9, h 4. Right circular cylinder tank with, it has a problem. No 1 over 3. Sorry. No need 1 over 3 because it's a cylinder. Phi r squared h. Sorry. Volume equal phi r squared h. Phi 9 into 4, 9, 9, 18, 36 pi. Are both equal. That only you need to show. Okay, මෙහෙම පෙන්නනවා නම් ඇති. Same value. Okay, that's a easy question. The cost of painting is 2,000 per 1 square centimeter for the spherical tank and 1,500 square meter for the cylindrical tank. Calculate the total painting cost for each tank? Good question. Now, first of all, I am going to calculate sphere area. Sphere area. How to get the sphere area? 4 pi r squared. 4 into 22/7. R squared means 9 because 3. 88 into 9 divided by 7. Square meter. Okay. Per 1 square meter, how about cost? 2000. Painting cost 2000 per 1 square meter for sphere. Then multiply by this number of square meters. So it square meter multiplied by number of the cost. Cost again multiply karan. The value multiplied by 2000. 226 point comma 28.1 rupees. Simple. Okay, next you can calculate cylinder volume area. Cylinder area. What's the cylinder area? 2 pi r h plus 2 pi r square because closed cylinder. Now 2 into 22/7, radius 3, height 4, plus 2 into 22/7, r squared mean 9. $528 divided by 7, 75.428 plus 44 into 9 over 7, 56.571. Okay, you can get the total area. $131.999, approximately 132, no? 132. Okay, no problem. Okay, then cost we can calculate. Cost එක හදාගන්න per 1 cubic centimeter, per 1 cubic meter 1500 cost. 1500 cost. Then multiply by 131.999 multiply by 1500. Very simple. Multiply by 1500. Answer මෙතනින් දාන්න 197,998.5. 197,998.5 rupees. Okay, they are very simple, grade 8 questions. You can calculate. Okay, I rapidly calculated. They are simple. Okay, I'm going to next part, final part. Yeah, that one important. A metallic object is formed by a cylinder surmounted by a hemisphere. Yes. The common diameter 21 centimeter, that means radius 10.1, 10.5 radius. And the height of the cylinder 14 centimeter. Calculate the curved surface area of the entire metallic object. Calculate the curved surface area. Curved surface area means this surface and this sphere part curved area. Okay, first I can get this is the cylinder. This is the hemisphere. Okay, this object. Now, the curved surface means the outer surface of the cylinder plus outer surface of the, it's 10.5 is the radius. Okay, outer surface area of cylinder, what is the equation? The area equals cylinder 2 pi RH plus the outer surface area of sphere, hemisphere, then it is 2 pi RH. 2 pi RH, 4 pi R divided by 4 pi RH divided by 2. Same equation. Now 2 pi RH plus 2 pi RH, not H, 2 pi R square, sorry, 2 pi R square. 2 pi RH into how about the height? 14 centimeter. Ten 10.5 to 10.5. 10.5 to 10.5 3 to 3. 2 and 17, 7. Okay, now 44 to 21. 924 924 plus 44 into 3 into 10.5. 1386. The answer was 2310 square centimeters. 2310 square centimeters. Final question. That's the full curved surface of the object. I got the curved surface of the cylinder and curved surface of the sphere, hemisphere. Do we need to get this bottom? No, bottom is not curved surface, it's a flat surface. Flat surfaces you don't need. Did you understood? Kabir, any doubt? That easy. Final one. Find the total volume of the object. Okay, total volume. Total volume of the object. Okay, first I can get the cylinder volume. Cylinder volume. 1/3, not 1/3, 5r squared h 22/7. R squared mean 10.5 into 10.5. Height 14. 2 and 3. These cancel into 7. 66 into 10.5 into 7. 4,851 cubic centimeter is the volume of the cylinder. Then you can get the volume of the hemisphere. Hemisphere volume. 2/3 5r cube, because it's hemisphere. 4/3 is a sphere volume. 2/3 radius 10.5. 10.5 cube. Now it is 2 and 3. 2 and 22 cancel into 11. 3 to 3 cancel. Now 11 into 2, 22. 22 into 10.5 into 10.5. Cubic centimeter. Okay, total volume. Total volume. Four 1,851 plus 2,425.5. This is answer for total volume. $7,276.5. They are very simple question. That's why I rapidly completed this calculation. They are very basic question. I just want to revise your equations. Area volume equations tika matak karne ka tama. That was my purpose. This type simple questions not coming in exam. I just want to revise again your equation of area and volume. I think everything remember equations. Okay, any doubt of exam number 2 paper? Have we completely discussed? Any doubt? Tanya? Yeah, this is the final answer. 7,200 76.5 cubic centimeter. Okay, others, Fatima, everything okay? Yes. This part, yeah, the area. Now, why again divide into two? Normally, sphere area 4 pi r squared, but I got 2 pi r squared. Then why again divide into two? Yes, if you got 4 pi r squared again a full area, you have to get the half again. But I got only 2 pi r squared. 2 pi r mean only half. Any other doubts? Please go through this. These questions are very simple. I just want to revise again your equations. Dihini, everything okay? Dihini? Okay. Okay, that's the end of our exam paper. Next Sunday I hope to discuss electricity. I don't miss Sunday classes again. Electricity we doing final part of electricity most probably. Wednesday we can complete start magnetic fields, and Sunday we can discuss transformers. Then within 1 week we can complete electricity remain part, and next week we can start, next Wednesday we can start our new lesson. Okay, goodbye. Let's meet next Tuesday.